The Prognoz platform is a new generation platform designed to develop high-tech custom business applications on a turnkey basis. Also, it can be used as an independent, full-packaged solution. The platform has a broad range of tools for creating desktop, web-based, and mobile applications for data visualization, OLAP, reporting, and modeling and scenario-based forecasting of business indicators. Our own data warehouse designer helps build fully functional industrial BI systems. Prognoz platform combines advanced data discovery approaches and self-service BI with traditional business analytics applications. The Prognoz platform can be deployed in the cloud. Its flexible administration tools enable you to manage the rights of all platform objects. The Prognoz platform is an advanced platform that enables users to complete a broad range of BI tasks. Let's demonstrate some of the Prognoz platform's critical capabilities. Let's start with business user data mashup and modeling. We can analyze the sales for a particular United States company via the powerful capabilities of the Prognoz platform. To conduct the analysis, we will use the Dashboards toolkit. Let's open the data source. We can quickly identify that there is something wrong with the source data, as the mean is much different from the median. It shows that there are outliers in the source data. Using the embedded data quality capabilities, we can promptly find the problem data and, in this case, exclude them from further analysis. Now we will calculate the marginality of stores with the help of calculable elements of the dimensions that can make use of the rich function library. Let's display this information via the map by copying the source block and changing the visualizer type for the map. We can easily display the specified stores on the map by selecting them as geolocation objects and highlight the desired indicators in color. Let's continue analyzing the data. We'll add one more block by copying. We need to calculate the average relative yield of the stores. To do so, let's place the stores in the columns and add one more calculable indicator to be used as the source. In case we forget how it was calculated, we can easily navigate among the various calculable indicators and view their formulas, and set the aggregation in such a way as to calculate the mean value. Let's select the top 5 stores by this indicator and display this information through a visually compelling chart. Let's make the selected states and stores be displayed automatically after highlighting the data in the table, and customize the chart to display only the selected stores on the map automatically. With the Prognoz platform's embedded tools, you can easily build the logic that solves a specific data analysis task in the report. Now let's add the report's heading and design it. If we need to manage the dates according to which the report is built, we can set and customize this parameter with little effort. Now assume that we have an Excel file containing additional indicators for this data source, such as return of goods for various reasons. We can easily load these data via the import wizard. Let's select the file. We can import data in the form of a table and a crosstab as well. If necessary, we can clarify the proposed parameters, but in this case, it is not required. We can load data to both existing and new sources. In this example, let's create a new source that is return sales and specify where it will be saved in the repository. Similarly, we can create new dictionaries or use existing ones. Let's connect to the existing ones. All the required data structures are created automatically, and the data are loaded from the file to these structures. After the data have been loaded, let's change the placement and selection of the dimensions. For convenience, let's select the alternative hierarchy containing information only by the United States. Customize the data aggregation and display the return structure via the chart. We can combine several data sources by their common dimensions. For example, we can combine the initial sales data source and the one that has just been loaded. Change the dimension hierarchy and make the selection in the particular dimensions. You can change the chart type and save the report. The next 3 critical capabilities are presented in one video, since they are tightly tied within the Prognoz platform. When we developed the Prognoz platform, we paid special attention to its internal consistency and integration ability with other applications. Let's consider an example where we move data and metadata from one of the report types, in this case a dashboard, between different repositories. This mechanism enables us to solve various tasks, such as moving a new report from the development and testing environment to the production environment. Suppose that this dashboard was created in its own repository, and now we need to migrate it to the enterprise warehouse. Obviously, when creating the dashboard, additional dictionaries and data sources containing data that are not available in the enterprise warehouse could be created. It is also important to note that the dashboard is interactive. In particular, when you change a date, the dashboard refreshes. To move an object from one repository to another, the Update Manager is used. Let's add our dashboard to the update and open the Update Manager. We can see what objects are needed for this dashboard. In turn, each of these objects can use other objects, which are displayed in this window as well. Now we can select these objects and also add them to the update. For each, we can set what to move: data, metadata, or both. Let's select both. Let's apply this setting to all objects of this dashboard. Then let's arrange objects in the update so that they are arranged in the order of dependencies. Now we can exclude from the update those objects that you consider for any reason unnecessary to move. We can edit object transfer settings. For example, let's change the method of object identification to identifiers. All settings are done, and we can save the update to File. Now the administrator of the Enterprise Data Warehouse can enter it. Let's open the desired file that contains all the information about our dashboard. We can see the list of objects that were previously added to the update file. Make sure that no conflicts are detected and run the update. A new folder containing the loaded report appears. Let's open it and make sure that it works. Now let's move transferred objects to folders in accordance with the Enterprise Data Warehouse organization logic. Now we can specify access rights to the report for different users. Let's start the Security Manager, with which we can centrally control access to the data, metadata, and tools of the system. For users and user groups, with or without domain authentication. The Tools section is used to control integrity, checking the user lockout mechanism, and working with security policy backup copies. The Users section is for managing user accounts, which represent the security subjects of the system. Each account has specific rights for working with system objects. User properties refer to parameters such as name, description, password, group membership, access category, and access time. The Groups section is for managing user groups representing security subjects of the system. The main purpose of a group is to bundle together multiple users under one account name to unify control of access rights. The Privileges section is used to delimit privileges of security subjects. For each privilege, we can specify the list of security subjects having this privilege. The Mandatory Access Control section is used to create a list of security categories and levels to be used for rights delimitation. The Policies Editor section is used to set rules defining methods and levels of security of the application system, including flexible settings for the password policy. The Auditing section is used to set auditing of user activities on the system. The system can automatically audit actions of subjects on the system and record information about actions made in the access protocol. Each object type has both general actions and actions specific for this object type. You can track all user actions using the Access Protocol, which is logged automatically by the Prognoz platform. The Access Protocol enables you to view objects hierarchically or in flat format. Because the Access Protocol contains a large number of entries, for ease of use, you can apply flexible filter rules. Let's create an example of a filter. Let's select specific actions, for example, read. Let's select a specific object type, for example, the regular report. Let's also select a specific user. By applying the filter, we can easily get the desired list of actions. Let's disable the filter and continue setting access rights for the loaded dashboard. We'll provide public read access to the object, but we'll forbid modification of the report and the objects contained in it. Let's permit read access and modification for the report and the objects contained in it for the Finance Administrator user group. All the security settings are applied centrally, regardless of the client type. Let's try to open the report via the web browser. Let's log in as a user having edit rights and go to the Object Navigator. We can edit and save the report. For example, let's edit the chart style. Now let's log on as a user with no edit rights and go to the Object Navigator. Since the user doesn't have edit rights, the edit action is disabled. Another ability of the Prognoz platform is to create an ad hoc semantic layer, which enables us to perform a wide range of tasks, such as creating topic-specific data marts. Let's create an example of these semantic layers. To do so, let's use the Prognoz platform object named Workspace. We can place it on any object. Let's use the same dashboard. Please note that from the local menu, we have access to the complete list of actions with this object. For example, we can view its component objects. Now, in just 2 clicks, we can place these objects in the workspace. This action can be applied to any objects. If necessary, we can place these objects as desired. The virtual cube object enables us to combine a number of different data sources. In our case, they are return sales and sales USA shop. Return sales is an example of how the Prognoz platform enables us to model data using the top-down approach, when we can access the existing database tables to create a multidimensional data view. We can implement this approach using a special wizard. We access specific table facts and bind dimensions to specific table columns. Moreover, we can use additional services such as calculable facts and aggregation, which are accessible in this wizard. The Sales USA shop is an example of how the Prognoz platform enables us to model data using the bottom-up approach, when we can describe a logical structure of objects, while all the necessary data structures are created automatically. We can describe attributes that, in turn, can be links to other dictionaries, for example, the countries dictionary. Using the semantic layer, we can make new queries, including to different data sources, by combining them in one query. We can see that by selecting table data, we display the corresponding data on the chart for each particular data source individually, as well as the combined data sources, including using different types of charts. Let's save the report to the repository. Let's add this report to the semantic layer. Let's continue by adding objects that are of interest to us. In particular, we are interested in the source database and its settings. If necessary, we can change them by selecting from a large number of available types of databases. We can change authentication type and other settings. Likewise, we can open any dictionary for editing, for example, the sales indicator. We can change the structure of the dictionary and edit its elements. We can enable additional services, for example, delimitation of access rights at the level of dictionary elements. Let's add the public and community user group and a new user. Let's set access rights for specific dictionary elements. Let's enter the name for the semantic layer. And save it. Let's log on to the repository as the user that we added and open the semantic layer. After we open one of the reports, we can see that not all elements are displayed in the sales indicators dimension, but only those that are accessible to the specified user. Apart from working with relational databases, the Prognoz platform enables you to work with multidimensional data sources. We can access any multidimensional data source using predefined database types, as well as to connect to other data sources via a special driver. The Prognoz platform imports multidimensional source metadata automatically. All the platform capabilities are supported. In the Formula Wizard, you can use specific commands supported by multidimensional databases, such as top count. Use the embedded search tool to orient yourself with the diversity of the existing repository objects. The search tool enables you to set search conditions and find desired objects easily. The Prognoz platform also enables you to merge different tables that can be physically located in different hardware platforms and even different database types within a single source. For example, we can combine detailed and aggregate data that are located in physically different tables within one source. Moreover, we can set optional functions such as filter strategy. The flexible platform architecture ensures the platform's cloud deployment. The Prognoz platform has built-in data management capabilities, including data integration and data warehouse, connectors to cloud-based data sources, which ensures direct connection for both cloud and on-premise data sources, and packaged content. The Prognoz platform has everything needed for cloud deployment. Currently, Prognoz offers this service for familiarizing you with its features and capabilities. The service is available from the Prognoz website. While designed for demonstration purposes, the service enables you to use all the data analysis capabilities of the Prognoz platform. Let's consider an example in which a chain store analyst uploads data to the cloud for later analysis. The interface and functionality of the cloud version of the platform do not differ from the Prognoz platform web application. After logon, the user has access to all user tools, predefined data sources, and reports. The user can upload custom data sets using the import wizard. Let's load sales data. In a few simple actions, we get a ready-to-use data source. Let's perform data analysis and save the report. Now the report is accessible in the cloud for further data analysis. The Prognoz platform also enables you to connect to cloud data sources using its ability to create connections to data sources via the web service. In this case, the cloud is considered to be an ordinary database. Data use in the cloud is no different from other data access methods, such as access to a relational database. Cloud data can also be used for creating multidimensional data structures. Cloud data sources can be used with local sources on a concurrent basis. In our case, suppose that the company analyst analyzes sales and wants to add data about stores previously imported to the cloud. Let's open the existing dashboard. Let's add to the dashboard a new block that is based on the cloud data source that we have created. Links between report elements are set the same way as for any other type of data source. For the user working with the report, there is no difference what types of data sources are used in the report. The platform architecture enables you to deploy it to any cloud, private or public. Auto or manual scaling is provided at all three tiers of the architecture using cloud infrastructure provider tools at the level of the database or the database as a cloud service, at the level of the BI server, as well as at the level of a web application or site. The cloud architecture represents a set of virtual machines. You can connect to any of them using RDP or other similar software. To demonstrate the administration and scalability features of the cloud architecture, the Prognoz platform was deployed to the Microsoft Azure cloud. When a third-party cloud provider is utilized, we recommend that you use the provider's administration features. Another example of using the Prognoz platform in the cloud is Prognoz Data Portal, which is custom commercial software built atop the platform. Prognoz Data Portal is an all-in-one big data platform designed to work with terabyte information and analytical databases. It combines tools for the high-frequency processing and analysis of large amounts of heterogeneous structured and unstructured information. Prognoz Data Portal's data warehouse contains over 200 reliable information sources from Russia and all over the world, including the International Monetary Fund, the United Nations, the World Bank, and so on. The Prognoz Data Portal provides 4 sections: indicators, datasets, reports, and publications. Each section comes with a search feature that enables the user to type a query in the form of text. You can additionally classify search results by topics, providers, regions, and periods, and filter them by ticking checkboxes next to the desired elements. You can also see which elements contain data and which are empty. This simplifies the search process for the desired information. Let's type number of arrivals in the search box. You can immediately see search results displayed as a chart, which enables you to find desired information at a glance. Using the search box, you can specify additional information, such as the desired countries, or you can select these elements via the visual interface. You can add the result to your bookmarks for later use. Now let's find another indicator. The indicators that we selected earlier are available as bookmarks. Now we can open the data that we found using the tools provided in the Prognoz platform. Let's see this in dashboards. We can build reports using the full set of the Prognoz platform's capabilities. Output reports can be saved or exported to the desired file format. The next two critical capabilities are presented in one video, since they are tightly tied within the Prognoz platform. The Prognoz platform includes programming and visual tools and a development environment for building reports, dashboards, and queries, and performing analysis. The Prognoz platform has a full-function application development environment, which enables you to create an analytical application easily. Let's give some examples of embedding. First, let's consider an example for the desktop application that displays the existing reports in the repository. Let's select one of the reports to illustrate the embedding process. The Prognoz platform comes with a form designer, which enables you to create such applications. In our case, we can see the entire code needed to create an application. The component library appears on the left side, with the properties panel on the right side. The developer can use Code Inspector and the Class Inspector. The form designer enables the developer to create application forms using the component library and properties panel. Let's launch the form. In this example, the filtered repository object tree appears on the left side of the form, and the selected report is displayed on the right side of the form. If we select the same report, we will see that it looks the same way as it looked from the system interface. The Prognoz platform supports integration with the .NET platform. This enables you to work, for example, in Visual Studio and use one of the available programming languages, such as C#. You can use the same data visualization components as you can in the embedded development environment. Like the desktop client, the Prognoz platform has a rich visual component library for web applications. Now we'll see examples of various available components: color panel, date time picker, and progress bar. Apart from ordinary low-level components, the Prognoz platform's library contains high-level components like tab sheet, tree list, and ribbon. It is important to note that the component library also contains numerous chart types for displaying various charts, such as line charts, area charts, and others. The embedded map engine enables you to display indicator values by filling regions in color, indicate flows between regions by arrows, and display microcharts such as bars, bubbles, and pies. The timeline is supported as well. A key feature of the Prognoz platform is that it can be seamlessly integrated into other systems. As an example, let's consider integration with Microsoft SharePoint, where the workflow is provided using the tools of this application, while the budget planning is fully performed by the Prognoz platform tools. The Prognoz platform tools enable you to perform all budgeting tasks, such as describing the sequence of calculations, setting up a formula for each calculation step, creating report forms to set up scenario data, visualizing outputs at each calculation step, organizing report calculations, sending emails, and so on. Using the SharePoint tools, we describe a workflow that, in our example, consists of 3 steps. The interaction with the Prognoz platform is provided at every step. The Prognoz platform supports the performance of various scheduled tasks and event-based tasks. As an example, let's set up the following workflow. Suppose that we have a United States economic forecast model. We want the model to run automatically as new data appears. We want to check the model output for compliance with specific rules. And if everything is okay, we want to email the report with calculation results. Using Prognoz platform tools, we specify that when new data are successfully saved to the source, the designated modeling task must be launched. Let's check the results using validation rules. For example, let's analyze whether the growth rate is correct. If we are successful, we send the report in the desired format by email. Now we can make changes in the data source, such as by using the write-back functionality of the Prognoz platform. Let's change data by drawing on the chart, and then let's save the changes. As a result, we receive an email containing model calculation results. The Prognoz platform supports integration with Hadoop. You can visualize and analyze output data from Hadoop using the BI tools of the Prognoz platform. You can create your own queries in HiveQL. To connect to Hadoop, select the corresponding driver. To access the Hadoop data, use queries in HiveQL. You can also use the existing datasets. You can build dimensions, cubes, reports, and other objects. All further work is no different from work with any other type of data source. Embedding also entails the use of third-party products and libraries from the Prognoz platform. Let's demonstrate this through an example of integration with the R library. First, let's select series and apply embedded methods of the Prognoz platform for forecasting, such as linear regression. Then, let's do the same, but with R methods. In this case, the calculation results match. Not only can you use predefined methods, but also you can use any other methods from the R library. Let's write a formula using R notation. We can also apply any custom code, such as for the Baxter-King method, via connection to a local file containing pre-written code. Let's open the Baxter-King text file with pre-written custom R code. This code calculates the Baxter-King method with similar parameters as the Prognoz platform. Let's use this file to calculate using the Baxter-King method. The next two critical capabilities are presented in one video, since they are tightly tied within the Prognoz platform. The Prognoz platform comes with free-form interactive exploration features, including interactivity and exploration, user experience, information visualizations, disconnected exploration, search-based data discovery, and data flow. The Prognoz platform has all the tools for traditional styles of analysis, including OLAP and ad hoc queries. Let's consider a specific example of conducting free-form interactive exploration and traditional styles of analysis via the Prognoz platform. We'll use the BI search function, which enables easy data searching by headings and content of the data sources. Now let's use the drag and drop capability to drag the desired search result to the workspace. We can add a static or dynamic heading. Let's create a dynamic heading to manage the selection by the calendar. Define the necessary data slice, and perform a few simple actions to enable data aggregation by fixed dimensions without exiting the toolkit. Similarly, you can enable in-memory caching, which will speed up analytical data processing. Use the alternative hierarchies to provide the data representation required for the selected report. You can also use arbitrary attributes of the dictionary, for example, the country ISO code. You can apply customized design settings for the entire table and each of its individual components, auto-fit the width and height of the cells, and set the report's header and side head. The toolkit also offers rich design capabilities. You can change the design of the table by applying predefined styles with a single click, or by highlighting the data based on their values via the predefined conditional formatting templates. You can also apply the display of growth indicators. The tabular view provides simultaneous display of several metrics. The metrics can be displayed with different fill and font colors and font sizes. Each metric has its own legend. You can undo any of your actions, which simplifies analysis, since you can come back and continue analyzing in another direction. You can also process the report without using the left panel, since the key operations for table management can be performed right from the table. You can easily exclude unnecessary data from further analysis, add new data for analysis, or analyze only the selected data. You can add calculable elements and analyze them using all the available Prognoz platform functions and external libraries. Let's build a forecast for the world sales indicator. Set the method parameters and specify the sample period to identify the equation. We can arbitrarily change any dimension. For example, we can move the calculable element up the hierarchy. Working with the calculable elements of the dimension is no different from working with the ordinary elements. Now to view the data on the chart, let's enable the report's layout. Insert the chart, and the calculable elements will appear on it like the dimension's ordinary elements. We can customize the chart's representation. For example, let's display the source data as columns and the forecast series as a line. For further analysis, let's delete the chart and the calculable element. In addition to the tabular view, analytical queries may include various types of visualizers. For example, let's add data visualization via the tree map component. Now let's select the indicators corresponding to the color and size of the rectangles in the tree map and analyze the dynamics of their value change using the timeline. The tabular and graphic representations are automatically synchronized, which is helpful when analyzing the selected elements of the table. Similarly, you can manage the table from the tree map. All the visualizers support the same data detailing, filtering, and sorting options as the tabular view. You can also perform data drill down analysis via the tree map component. You can easily navigate among different types of visualizers. Let's change the tree map representation to the map representation. The operation logic of all the visualization components is standardized, so the map changes automatically depending on the selection in the table, much like what we have already seen when using the tree map. The map also supports navigation through hierarchy levels. For example, we can drill down into Asia. In this case, the map changes automatically, and it also changes when we select a particular region. In addition to the fill of the territories, we can locate additional metrics on the map, for example, in the form of bar charts or pie charts. The map also supports the timeline to analyze the dynamics of indicator change. To get an overview of the dynamics of all the indicators concurrently, you can display spark lines in the table. Consider this report sheet to be prepared. Let's give it a meaningful name and add one more sheet. The report may contain several sheets and analyze data from a single source or from multiple sources. Let's continue analyzing the data. Enter sales, USD, Okinawa in the search box. The flexible filtering settings enable us to set the representation in accordance with any particular needs. For example, let's filter the values that meet the sales cost total return less than 30 million formula. Then we can sort the selected column ascending or descending. Also, the data visualization can be changed in accordance with an analyst's needs. For example, we can transform the absolute values into growth rates, or show the values as ranks, and use other filtering and sorting conditions, such as displaying the top 10 elements or a specific number of maximum and minimum elements. Let's display the analysis results via the accumulation chart. Place the legend wherever you need it, for example, to the right. Select data in the table to determine what appears on the chart. Suppose that we need to analyze the data on the map. Delete the chart, leaving only the selected stores. Let's change the hierarchy of the country's dimension to the alternative hierarchy. Select all the elements and enable the map. Now we can display the stores on the map in the form of markers. The marker color also depends on the selected metric's value, for example, sales. Enable the legend for the markers. Consider this report sheet to be prepared. Let's give it a meaningful name and add one more sheet to continue the analysis. Now let's find the total return USD indicator. Customize the slice placement and all the calculable indicators. Select the calculable indicators, select all the stores, and sort them by the total return. Let's add a bubble chart. This type of chart is helpful to analyze several metrics simultaneously. Let's place the sales metric along the x-axis. Then place the profit metric along the y-axis, connect the bubble size to the total return metric, and connect the bubble color with the profit share metric. Let's exclude the statistical outlier from the analysis. Now we can analyze the dynamics of the selected indicator's change via the timeline. Similarly to other visualization components, the selection in the table filters the data represented in the bubble chart automatically. Consider this report sheet to be prepared. Let's give it a meaningful name and add one more sheet to continue the analysis. Let's find the desired indicator. Drag the indicator to the sheet, add an interactive heading to select the period and the store, and customize the slice placement. Now we can easily drill into the information down to the source data using the drill down to relational data capability. Now all the data are available, including those that are not represented in this multidimensional source. So we can analyze these data using the entire functionality of the toolkit. For example, let's calculate the column total. We see which goods were returned to the particular store during the selected month. You can visualize the data as a chart. Change the selection in the store dimension to see the detailing for the selected store. Let's rename the sheet and save the report in the repository. And in a prepress file that enables us to save the report together with the data to perform offline analysis. We can load all the data or only the desired data. Double-click to open the report from the desktop in the desktop application, and open it from the repository in the web application. The Prognoz platform provides the flexibility to load data, which can significantly simplify subsequent work with data sources. For any data source, including those obtained using the Data Import Wizard, you can open the load operation as an ETL task. This means that data load is not a one-time operation. Upon completion, we do not need to lose all the information about its settings. On the contrary, when we open it as an ETL task, we can see that all the settings are saved both for a source Excel file and for a data source to which data were loaded. Moreover, using rich ETL task features, we can set up more sophisticated actions during data loading. For example, we can add one more file containing additional sales data and combine data from these two files. Let's add a new Excel file and make the settings. It's done exactly the same way as in the Data Import Wizard. For an ETL task, we need to make some simple settings to arrange operations as a chain. Now we can simply combine the results of the download of two files using the union operation. Let's set up input fields of two sources. Most operations are performed automatically. You just need to confirm actions suggested by the wizard. Let's define output fields using information about the data source structure. Done. Now we can execute it. More importantly, we can execute this task later on a schedule or based on any system or user-defined events. What we have to do is to make sure that new data are loaded. Now we can add loaded data to our dashboard and visualize values. The Prognoz platform enables users to create analytic dashboards and content. The Prognoz platform has the ability to create highly interactive dashboards and content with visual exploration and embedded, advanced, and location analytics for general use. The Prognoz platform enables you to create highly interactive dashboards using a rich library of visual components and maps for data visualization. You can analyze data using a variety of embedded tools, use existing and new data sources simultaneously, and perform offline analysis and many other manipulations. Let's perform step-by-step data analysis. Suppose that the purpose of our analysis is to create a dashboard to analyze macroeconomic indicators across countries. A report will include a number of sheets. Let's add the first of them. Using the Embedded Visualizers library, we can choose a method of data representation that best fits our needs. Select the desired data source using the panel on the left side of the screen. In a few clicks, we can choose the data representation that we need and at the same time apply an alternative hierarchy in the country's dictionary. To search for an indicator, use the search feature. You can easily filter the obtained results, and you can give a meaningful name to each visualization element. Let's add a chart to the dashboard. You can do this in many ways. Let's use a very convenient function such as duplicate, which also offers you layout options for the new block. Let's change the representation from table to chart using the context menu. Suppose that we want to see on the chart data not for all countries, but only for the United States. Let's add a title for this sheet and format it. Let's proceed with the analysis. Now suppose that we want to see the structure of the GDP growth. Let's use the duplicate function again. Let's change the chart type to pie and copy its name. Let's select key indicators that define the GDP growth. This can be done easily since the indicator dictionary contains the structure that we need. We can see that each year corresponds to a particular segment on this chart. At a glance, we can see changes in the structure of this indicator from year to year. If we are still not satisfied with the output, we can easily switch to any other data representation. Now, everything is okay. Let's add dynamics. The Prognoz platform provides convenient and very flexible mechanisms that enable you to synchronize different visualizers. You are not locked into a single option. Instead, the user defines what to synchronize. Suppose that we want to bind charts that are located on the right side of the screen via the countries dimension. All we need to do is to select both charts, click the link button, and select the desired dimension. Let's add a control to be able to switch between countries on these charts. We can add the control and name it easily. We can easily configure the dashboard's behavior. For example, if we want to choose a country using the table, this can be done in a few clicks. Suppose that in this report, we don't need this functionality. Simply disable this option. We can perform further analysis differently. For example, we can view various statistical characteristics of table data. We can analyze data by a country, which you can select either manually or based on a search. We can highlight table data using other available indicators. For example, we can bind cell color to the value of the exports of goods and services indicator and bind font size to the value of the imports of goods and services indicator. The corresponding legend appears automatically. Let's view these data using a map. With the unified approach to the visual interface, we can display values of other indicators using microcharts. We can view changes in data over time using the timeline. We can use another type of microchart, such as the pie chart. We can then analyze data using the timeline. The beauty of the Prognoz platform is that all its analytical capabilities are accessible from any other tool. Let's perform data mining of data directly from the dashboard. Let's select data for analysis. Simply copy the desired block and select the desired indicators in it. Let's choose key factors as the analysis method. Let's identify relations between the GDP growth and other indicators. Therefore, let's deselect the countries column. The resulting report appears on the screen. The key factors method automatically splits data into ranges, where each range measures the degree of dependence of the analyzed GDP growth on other indicators. Each range has its own color. We can see that GDP, to a greater extent, depends on household final consumption expenditure. The report that we can see is an ordinary report of the Prognoz platform. This means that we can leverage all the platform features, from auto filter to the ability to embed this report into our dashboard. To do so, let's add a new tab and then let's add a new report. The Prognoz platform enables you to create new calculable elements directly in the dashboard. Let's add a new indicator. First, for convenience's sake, let's change the table layout. Let's move to the indicator's dimension, add a new element, and set up its formula using the context menu. Let's proceed with the analysis. Now we want to build a forecast. In fact, we can do this via calculable elements, but we'll use another Prognoz platform feature. Let's select the desired data and go to the special Time Series Analysis tool. Literally, in a single click, the selected data appears on the screen, this time in the Time Series Analysis tool. This tool enables us to apply various functions to time series with a trivial amount of effort. Let's build forecasts for the selected series. Let's apply the Auto Trend function to two series and the ARIMA function to another series. For each of the series, we can easily change the parameters of the selected method. We can view all changes on the screen instantly. For the Household Final Consumption Expenditure series, let's use, for example, exponential smoothing, which can also be used for building forecasts. Now just select the calculated series together with the GDP growth series and apply linear regression to them. We can change the calculated series dynamically. Let's select GDP growth. After playing a little bit with the settings, we get the output that we need. Now we can name the report and save it. Also, we can easily embed this report into our dashboard. Let's do this on a new sheet. Let's do something knowledge intensive. With the modeling and forecasting tool, let's forecast GDP using the Solo model. It's not hard to guess that this can also be done directly in the dashboard. First, let's prepare data. Let's launch the modeling and forecasting tool. While using more sophisticated mathematics, the model is based on three variables that we selected in the dashboard and that automatically appeared in the workspace of the model. We can view data while selecting the desired variables. Let's start from the employment in industry variable. We create its dependence on itself and calculate it using ARIMA. Let's play a bit with the method parameters. As soon as we are happy with the result, let's see the forecast. As any statistical method, ARIMA has an allowable variation of results. To display more statistically significant results, enable chart corridors. Power users can use other features, in particular, the specification panel. Let's create a new equation for bank capital, which depends on GDP and which is calculated using the linear regression method. Similarly, this variable will depend on itself during the calculation. The modeling and forecasting tool provides flexible settings for equations. For example, for this equation, we'll apply output variable transformation, which is needed for the Solo model. Also, we can easily set transformations and lags for equation factors. We can apply transformations and view results interactively. We can also relocate the variables in the workspace as desired. The last equation is the Cobb-Douglas production function. We can set it up by a nonlinear regression equation, which is also available. But we'll perform an equivalent transformation and write it as a linear regression function, thus demonstrating how to apply transformations to the output variable and factors. In fact, we merely need to apply a logarithm to them. Done. The model is ready. Let's save it. The difference of this model from the one that we created using time series analysis is in the complex dependencies between variables. Modeling and forecasting is exactly the tool that enables us to create such models. All we need to do is to run the model calculation. Now we can view the forecasts that we received for each variable. We can also view them in a predefined report. We can fine-tune it a little bit and save. As you can guess, this report can be easily inserted into our dashboard. To give the final touch to the report, let's use display functions such as growth indicators and sparklines. Our dashboard is ready. Certainly, you can save it to the repository like any other Prognoz platform report. You can also save it to a file for later analysis. You can open it at any time, both from the desktop and from the web interface, like we are doing right now. The Prognoz platform provides capabilities to create highly formatted, print-ready, and interactive reports with or without parameters. The platform comprises production reporting, distribution, and printing, parameterizations and filters, report and dashboard navigation and guided navigation, a design environment for document layout, and a rich set of visual components. Reporting is a traditional BI task. The Prognoz platform offers a set of unique capabilities to create ad hoc reports. Let's consider the task of generating an interactive, print-ready report. Assume that you have a group of enterprises, each of which has specific goods and cost items. All these parameters depend on the calendar, so enterprise names and the list of goods and cost items can be changed. We need to analyze this information within a single report. Under normal circumstances, it's not easy to create this kind of report. But the Prognoz platform has embedded parameterization capabilities for all objects, including dimensions, cubes, and reports, which drastically simplifies the process. For this demonstration, we will use the existing data source. Using the batch export function, we can export the report to several files at the intersection of the selected report parameter elements. Just select the desired elements and specify the format of the resulting files and the output folder, and the platform exports the reports automatically, each of them containing data that corresponds to the selected parameters. Let's create a new report. Select the desired data source. Perform a few simple actions to place the data on the sheet and customize the representation. The Prognoz Platform Report Designer combines the established simplicity of an Excel-like interface with the flexible capabilities of the Prognoz platform. For example, you can manage dimension placement with or without a hierarchy, enable or disable the collapsibility of the dimension's child elements, number the report columns and rows, which is highly desirable in corporate reporting, and so on. You can also visually emphasize selected elements of the dimension quickly and easily. For example, let's select the first level of the cost items dimension. You can adjust the column width accurate to a millimeter, display the units of measure. We can insert headings that will be dynamically changed depending on the selection. And we can design them. Let's prepare the report for printing. First, let's hide the grid and the row headings. The Prognoz platform helps you to customize the print parameters easily and broadly. You can select the paper format and orientation, scale the report to fit the page width, set headers and footers with support for text and graphics, and add page numbers and headers on each page. You can also open a preview of the printed report. Let's change the sheet title, arrange the table corner, add the Manage Parameters capability to the report, and add the Date parameter. Then let's set the parameters link to the data source. The parameter controls can be placed right on the sheet. It's also possible to specify the parameter scope. You can restrict it to the current sheet or set it up to control values throughout the report. Let's set the second parameter in a similar manner. To perform further data analysis, let's add a second sheet to the report by copying the existing sheet and changing the selection and the arrangement of dimensions. You can use data from various sources in a single report and even on a single sheet. Let's add one more source to the report. Place it right under the first one. Customize its arrangement and selection. Add the units of measure to the display. And turn off the duplication of headings. Let's add a cost structure chart by selecting the histogram chart type. Here we can add data directly from the slice. Let's add a second chart that receives data from the sheet. As you can see, we can use data from various sources to build the charts as data from various slices are added to the selected cells on the sheet. Now let's set the selection synchronization among all these visualization elements by date, by organization, and by good. Now the visual components are changed synchronously when the selection is changed. Use the embedded capabilities of the Prognoz platform to customize information detailing. To provide data detailing on the current sheet by selecting data from the first sheet of the report, let's do the following. Enable detailing and customize its parameters. Now you can simply click the heading to switch to the second sheet. The Prognoz platform report designer offers a broad range of capabilities to build simple and complex reports based on one or several sources. You can include various visual components and customize navigation. You can also implement additional automation features through FOR, the platform's built-in object-oriented programming language. The Prognoz platform provides for easy content publication on mobile devices. The Prognoz platform enables you to develop and deliver content to mobile devices in publishing and interactive mode, and it takes advantage of the native capabilities of the mobile devices, such as performance and touchscreen and offline mode exploration. The Prognoz platform enables users to publish reports on mobile devices easily. Assume that there are several prepared reports to be published on a mobile device. We have the OLAP report, the dashboard, and the Pixel Perfect report. To publish reports, we need a special repository object called the Mobile Application Container. You can specify any kind of heading and an identifier for the container being created. So we can create several similar containers and publish specific reports in each of them. This is one of the data access control tools. The Prognoz platform provides flexible settings to delimit data access rights. This feature is also available in mobile applications. Let's configure access rights for the particular user. We can create reports right in the container in an ordinary folder, or just insert labels for the existing reports, and this will be enough for publication. Now we can publish reports. You can customize settings, including the virtual directory and others for each mobile application container. We can publish all the reports from this container, or just the selected ones. We can also specify the parameter values to be published, and the selected values will be available from the mobile device. Start publishing. Done. Let's launch the mobile device. We can use the existing connections, but since we created a new virtual directory when configuring the mobile application container, we will specify its parameters. It's necessary to specify the username and password. So we connect to the server. Although we added 4 objects to the container, the specified user is authorized to access only 3 of them, and they are available in the list. We can download all the reports with a single click. The Prognoz platform's mobile application works offline. Thus, all the required data and metadata are loaded. Let's make certain that the reports look the same as in the desktop application. The Prognoz platform enables users to view reports and process them as well. We can apply advanced customization, for example, to change the chart type easily. We can also customize the grid, highlight the data by their values, and enable representation in the form of a sparkline. We can sort data with little effort, and sophisticated users can create their own calculable elements. You can display the data through the various visualization components and change the settings broadly, including changing the number of groups. We can also display the data on the map that looks the same in both the desktop and mobile applications of the Prognoz platform, including the display of hints, 3D view, and the timeline. Let's open the dashboard. There are two modes used to view the dashboard. You can view the report as a whole or as a set of slides where each visualizer is maximized. This is convenient for the smaller screens of mobile devices. In this mode, you can easily navigate among the slides using gestures. Let's open the report. The report supports parameterization. If you change the parameter value, the report, including the name of the selected company, changes. Publication via the mobile application container is a powerful and flexible tool, but it requires specific user skills. To make the publication simpler, the Prognoz platform offers to save the report as a file of a specific format and then send it by email. We receive the email on the mobile device, open the file, and work with it in the same way as when publishing via the container. For example, we can change the report. Now we can share this modified report with other users from the mobile device by email. It's possible to open this message on another mobile device and see the changes made by the previous user. We can send screenshots by email in one click with the ability to add notes. The Prognoz platform has embedded collaboration and social integration capabilities. It enables you to share and discuss information, analysis, analytic content, and decisions via discussion threads, chat, and annotations. The Prognoz platform enables you to organize collaboration between users, even when they are far apart from each other. Let's see how it might work. Suppose that one of the users, let's say John, wants to perform data analysis together with another user, let's say Bob. John opens the desired dashboard and enables collaboration mode. The Prognoz platform automatically generates a link, which John must email to Bob. In our example, let's open the link in a new window. Bob can introduce himself. Pay attention to two things. Both users see the same report, including modifications that might be made by either of them. All comments are recorded in the conversation window. John: Hi, Bob. Can we discuss sales growth in Germany? Bob: Sure, John. Now John launches data analysis. Everything he is doing automatically appears before Bob's eyes. As they agreed, John performs data analysis to get data on top stores by sales. John: I've identified the top 5 stores by sales this year. Gelsenkirchen shop tops the list. However, this information is not sufficient for Bob. Right, John. Let's look again by sales margin. Now Bob takes the matter into his own hands and proceeds with data analysis by adding a calculable indicator such as sales margin. For illustration purposes, Bob displays the sales margin data on the secondary axis. Bob suspected something of the kind. Duisburg shop happens to top the list by sales margin, while Gelsenkirchen shop is only the 3rd. John is a bit surprised. That's interesting information. I'll share it with my colleagues. Thanks, Bob. Appreciated. The analysis is over. Now we can save the report. We can also share the analysis results with other colleagues via Discuss in SharePoint. Please note that John and Bob's conversation has not disappeared. But SharePoint is a corporate portal. What if we want to share the report with a wide range of users? You can do this via popular social media like LiveJournal. Another feature of the Prognoz platform is the storytelling component that enables you to convert your report into an interactive presentation composed of several slides to convey a particular story to the audience. We already have 3 slides in our report, which we can see by enabling the corresponding option. We can easily change the order of slides to present our idea more convincingly. Another useful feature of the Prognoz platform is that each dashboard component can be used individually. In other words, it can be embedded into a portal or application. For example, we like the top stores by sales chart, and we want to use it to share the information contained in it. The link that we get is unique. Therefore, it can be embedded into portals and applications, or it can be simply opened in a new window. Similarly, we can get a link for the whole document or an individual slide. You can move among slides in view mode and use the page up and page down keys for this purpose. All the dashboard's interactive features are supported, including the timeline.